Okay, so let's do an example of average rate of change. Okay, rate of change, if it's a linear function, that is just a reference to its slope. It's how quickly do the y values change as the x values change. So a similar thing that we know of would be your speed on the road. 70 miles per hour. That means that your position changes by 70 miles every hour. So we want to find a similar thing on this function for the interval -1 to 2. So that's from when x equals -1 until x equals 2. So when x equals -1, that's this right here. We're going to go down to the function and see what its value is when x is -1. Here we don't have the equation, so we're just going to eyeball it a little bit here. -1, -3.5 is what that looks like to me. -1, -3.5 until x equals 2. 2 is right here. We'll work our way down. And to me, it looks like 2, -3.5. So how much did the y values change? -3.5, -3.5. When you do average rate of change, after you find those 2 points on the graph, you would connect them, okay? So you're kind of making a new graph and saying, yes, we see that this thing goes up, and then it comes back down, and then it goes back up a little bit more. But if we just went straight from point A to point B here, what would the rate of change be? How much would the y values change as the x values changed? So that's just y2 minus y1 over x2 minus x1. So we've got -3.5 minus -3.5 over 2 minus -1. Doesn't really matter. It's 0 over 3, which is just 0. So on average, it's not changing from -1 to 2. Now obviously there is some change in between there, but we're looking at an average, which looks at a broad area and just averages it. This is not an even function or an odd function, it's neither. And then the interval is increasing and decreasing. Let's do that before we move on. Let me erase a little bit here. All right, let's start fresh. We're going to do intervals increasing and decreasing. And so, what in the world does the term increasing mean? What does the term decreasing mean? Those words are with respect to the y values. Are the y values increasing or decreasing for any certain part on this graph? Well, if you look right here, about right here, the y value is about 4. And then when you go over here, the y value is -6. So that is a decrease. It's moving downward. But when it gets to this point, it begins to increase. Okay? That is a minimum point. The minimum is where something stops decreasing and starts increasing. And it increases to this point right here. That's a maximum point, a local maximum point. And then it starts to decrease again, and then at this point right here, it turns one more time and starts to increase, and it never comes back down. It never stops increasing. Okay? So when you want to define these intervals, increasing and decreasing, you are telling when those things are happening. Like to increase, we know what that means. It means the y values are going up. We don't care how high they go, we just care that they are currently going up or they're currently going down. Okay, so we're going to look at not the y values here, but the x values. Okay. For example, this point has an x value of -2. So it's like -2, -7.5. But the y is not important, it's the x that we care about. So this function begins by decreasing, and it starts at -infinity. Okay, when x is -infinity, this y value is huge. It's way up here, infinitely high. And then as you come in from the left, eventually you'll hit this function and you will see that it's going down until -2. When x is negative 2, things change. It starts to increase again. So we go up here, put negative 2, increases until when? Right here it looks like maybe 0.25, 0.2, something like that, you know, being a little more exact than I can be with this one. So until x equals 0.25, this function is going to increase. Okay? Then when it gets to x equals 0.25, it's going to start decreasing, and decreases until maybe 1.8, negative 4-ish. I'll just put negative 4. The y value is not important there. It's when it stops decreasing, not where it stops decreasing. And then at 1.8, when x is 1.8, the y values start to increase, and they never stop. So it's infinity. So that's just the basics of rate of change, and also looking at intervals increasing, decreasing. Just for good measure, if you want to hang around, I'll do number 7. And we're looking for the average rate of change over the interval negative 1 to 1.5. So when x is negative 1, that is this point right here. It looks like the point negative 1, 6. Okay. So when x is negative 1, the y value is 6. And then when we go to 1.5, it's somewhere probably right around here. If I was guessing, which I am. Okay, you're having to estimate halfway between 1 and 2 is 1.5. And the x value, so the x value is 1.5, the y value is 5. So we want to find the average rate of change between those 2 points, which would be this line right here. Okay, the slope of this line is the average rate of change. Okay, yeah, it's going really fast in the negative direction this way, then it's going really fast in the positive direction this way. But if you were slow and trying to be efficient, how could you just walk straight from here to here? What would your slope, or what would the rate of change be? That's the average. So again, change in y over change in x. How much does the y change? y2 minus y1 over x2 minus x1. And the way you tell which one is which is that the furthest left is x1 and y1. Furthest right is x2 and y2. So we get 5 minus 6 over 1.5 minus negative 1. So negative 1 over 2.5, which is 2 over 5, or negative 0.4, the average rate of change. Okay? And you may get a different number from that, a little bit different, because there's some estimating that has to go into this. It's not right on a grid line. We can, at best, maybe get within, 0.25 of the actual number, just because our grid isn't perfect. All right, one thing they sometimes ask you on Khan Academy, I'll slide over to, or slide up to number 3. One thing they ask you on Khan Academy questions is about when is the interval positive versus negative, that kind of thing. Okay. Well, this function is even. So if the x values that they give you are the same number, one's just positive and one's negative, then that's a rate of change of 0. Okay, so look here, negative 3, it's about here, positive 3, it's about here. It's a straight horizontal line. But they might ask you, on what interval is this function's rate of change, average rate of change, positive? And they might say from one of the options, from negative 2 to 4. Okay, when x is negative 2, it's right there. When x is 4, the function's down here. We'll look here. Whoa. Lines are not the easiest thing on this. I'm looking for a positive rate of change, but this one goes downhill. You go from here to here. And that is not positive. So try a different one. They might ask you about negative 4 to negative 2. Negative 4, go down to that point. There it is. Negative 2 is right there. Average rate of change. is a line that connects, the slope of the line that connects the two, and it's uphill, so this is positive, and that would be your answer, okay? So there's rates of change, intervals, all that good stuff. Shoot me emails if you have questions.